This lesson, create searching methods. The objectives for this lesson are to create a searching design pattern. We're going to create a SearchBase class and then create a ProductSearch class. We'll add search methods to our product repository class and the interface, things like search, add where clause, and add order by clause. And then we're going to add a search endpoint on our product controller. When searching, a user may wish to search many ways. Maybe they want to search by name, and then they want to search by list price, and then they might want to search by name and list price, or any other combination of properties in your product class. Well, the problem is you don't want to have to add that many endpoints. So instead, let's create a product search class that has a list of all the things that they could search by, right? So whatever properties you want in there. Then you can add a single endpoint to accept a query with the different parameters, and it just simply maps to those properties. Let's create a base search class and a product search class. Right mouse click on the base classes folder, and let's create a new class called SearchBase. It's always a good idea if you're going to have many of the same types of classes to create a base class. In this case, what I want to do is also add on an order by. So instead of just searching, I also want to be able to set the order by. So how do I want the ordering to come back? Then let's right mouse click on the project and let's add a new folder called Search Classes. We'll right mouse click on this and we'll add a class called Product Search. And our product search is going to inherit from SearchBase. I'm going to add two properties, name and list price, that we can search by. In the constructor, I'll go ahead and set the order by to name. I want to be able to order by name when the records come back. And I'll set the name equal to string.empty. Let's now add some search methods to the product repository class. Open the product repository. And let's add a new set of methods here. So I've got a public virtual. It's going to return a list of products, and it's search. And we're going to pass in that product search class. I'm then going to create an iQueryable of product query equals underscore db context.products. So I've taken advantage of deferred execution here in link. If I'm just creating a query, it's not going to run the select yet until I pass that query and our search to the add where clause. So inside of here, I'm now going to build up a where onto this query. So I'm checking to see if the search.name is not string.isNull or empty. And if it isn't, that means there's something in there. So I want to do a search by that. So query equals query.where, row.name starts with search.name. So I'm just simply adding on a where clause. Then I'm checking to see if the list price has a value in it. And if it does, I will do some more where on there. So to be where the row.name starts with the whatever's in the name, and where the list price is greater than or equal to the search.list price. Then the next thing I do is I add the order by clause. So I come down here and I add an order by row.name. So if I pass in name there, then it's going to order by those particular criteria. And that's it. That's our search. Of course, we really want to add the search methods to our IRepository interface because we want to make sure all repository classes will implement a search. Open the IRepository.cs. Right now, it just is passing in the entity class. We need it to pass in the search class as well. So we're going to rewrite this IRepository interface now. We're going to be able to pass in two classes. So every repository class is going to have two now. One would be the entity, and one will be the search. So if we create a customer repository, we're going to have a customer entity object, and we're going to have a customer search. Because if you think about it, most times you're going to want to do this. Now, if you don't want to do the search, you could still keep the original iRepository, create a new interface called maybe iRepository Search, and then you decide which repository classes do what. But here you can see all I'm doing is adding on the tEntity, the tSearch to every single interface here. Now the problem is, once we do this, things are going to break, okay? Because it now needs a second parameter here when we're generating this iRepository. So we have to open the original one and replace it, we have to find all instances of this. So if we go to the product controller, we're also using that here, aren't we? So we need to put this here as well. Okay, so then what you could do is you go over to like the extension classes. You have to remember all the places, but you don't have to remember, of course. All you have to do is do a build, and it will tell you if you got all of the instances, and we did. There we go. And we are now ready to do the search method. So we just have to add our route into our product controller, and then we'll be able to apply searching to our APIs. Open up the product controller class, and right before the post is where I'm going to add a search route. So you can see the route here, HTTP GET, route is search. It could produce a 200, a 404, or a 500. Look at line 93. In the search method, I'm going to use the from query attribute in front of the parameter being passed in. The from query allows MVC to grab the items on the query line, any key value pairs, and map them to the properties in our product search class. And we'll see an example of this when we run this. Other than that, this code is pretty standard. We have a try catch. We go ahead and call our search on our repository class that we just added, passing in our search object. If the list comes back with something valid, we return a 200, passing the list. Otherwise, we return a status of a 404. And if there's any exception, of course, we're going to use that info message default from our app settings.json. And then, of course, we'll log any error as well. Let's go ahead and try this out. So we'll come down here, we'll find our search API. There's the parameters that it's finding from the product search. So maybe we put in something like an R, and then maybe fill in name here, and we execute. And we then get back a set of data where all of the names start with R. Now, look at the request URL right here. You see what we're doing. Search, question mark, name equals R, ampersand, order by equals name. So those are the name and order by that are getting mapped to the product search. Let's maybe add on the list price here. So now we're looking for any ones that start with R. Move down a little bit here. And the list price is $14.99 or greater. So you can see all of the list prices here are greater than that number. And we're also getting just the products that start with R. And you can just, do whatever you need here to do searching. Maybe do an RO, and now it'll grab just those that start with RO. So much less list of products being returned from this search now. But this is really neat because in this request URL, it's taking each of those parameters and automatically mapping them to our product search class. In this lesson, we created a base search class and a product search class. We added methods to our repository class to perform searching and sorting. We updated the IRepository interface to accept a search class. We took advantage of deferred execution in LINQ to build our query, and we added a search route. Coming up next, making asynchronous API calls.